Shambhu Das from Reno, I guess, University of Nevada, Reno, who will talk on quantum transport through fluids.
The topics of my talk is transmission of electric current through structural isomers of fluorine-14. The outline of my talk is motivation, which I will discuss about advanced and retarded Green functions. Then after transmission function, some graph of transmission function versus energy, and at the last, conclusion. Motivation. Dr. Frenner and his students are involved in the study of collective dipole oscillation and photoionization of C60 and C40 experimentally. At the same time, in my university, Dr. Krishnagisani, Dr. Barak from Germany, Dr. Peter Winkler in UNR are involved in the study of semi-classical explanation of vibration of C60 theoretically. The problem with Dr. Frenner was he could not distinguish the structural isomers of C40 because C40 has 40 different structural isomers, and he could not detect by photoionization method. My professor told me to resolve this problem, and I did by transport phenomena. I supplied current through different structural isomers of C40, and current flows through different ways of C40, and there is an interference pattern developed. An interference pattern is different for different structural isomers because path difference is different, therefore interference pattern is different. So a structural isomer is just number of atoms same, but structure is different. So path difference is different, and interference pattern is different. Therefore, isomer, in this way we can detect isomer. We can separate isomer, structural isomers. And actually, different fluorine has different structural isomers. C38 has different structural like this. C40 has 40 different structural isomers, and I'm getting transmission spectrum. Transmission spectrum is different for C2V, so this is symmetry, C2V symmetry. And other is C40, which has C3V symmetry. So in both cases, transmission spectrum is different because interference pattern is different. If we have constructive interference pattern, then transmission is maximum. If we have destructive interference pattern, then transmission is zero. It doesn't transmit. So in different fluorine, transmission spectrum is different. So I observe transmission spectrum for this one and this one. This one is C40, this one is also C40, this one has C3 symmetry, this one has C2 symmetry. Little bit we have to discuss to understand transmission function. Little bit we have to discuss about Green function, retarded Green function, advanced Green function. So probability amplitude that at time t1, we add a particle at R1 to an interacting system in its ground state, and at later time t2, we remove a particle at R2 such that system is again in its ground state. That is retarded Green function. And advanced Green function is similarly probability amplitude that we remove a particle at R2 from the interacting system, and at time t1, we add a particle to an interactive system such that system is again in its ground state. So this is source. It is connected. Source means gold here, gold plate here, and channel is that is molecule, fluorine molecule. So source has higher chemical potential with respect to drain, and the difference of chemical potential is electronic charge potential difference applied. So due to this potential difference, current flows in the whole circuit, and current density is given by this general formula, where N is electron density and D is deep velocity of the electron. Also we know this expression, electron density is related with the density of a state and Fermi function. Mu J is chemical potential. If you do not plug this expression here, then we will get this expression. Minus sign is due to some electron also diffuses from drain to source. Therefore, we have minus sign here. In this expression, T is transmission function. So for one channel, its value is 1 or 0. If there is a perfect constitutive interference, then T is equal to 1. If destructive interference takes place, then T is equal to 0. If you're going to plot this expression, this is density capacity and this is formula for this velocity, then we will get this formula. If we have to plot this expression here, then we get the formula of current density like this, and at 0 temperature, Fermi function becomes Heaviside step function. If you're going to plot this expression here, then we'll get this expression, and after solving this expression, we'll get current density like this, and this is transmission function, which is trace of this part, trace of this expression, where gamma S is coupling between source and molecule, and gamma D is coupling between molecule, that is fluorine, and drain. And this is retarded gain function, this is advanced gain function. So here my professor told actually if current flows through different possible path of fluorine, then what will be the intensity formula? Then I use film and path integral approach, and where this is the Broglie wavelength, lambda is equal to H over mv. Action on first path, current electron flows through this way, electron flows through this way, different path. So different path difference, there are n paths possible. If current flows through fluorine, then there are n possible path possible, and I generalize the formula actually, and then generalized formula is applied in fluorine. So this is general expression for intensity. So I designed this formula. So action of first path is given by this expression, energy times time, and energy is given by mv squared into T. Then it is split into mv into Vd. mv is replaced by this expression, S over lambda, and Vt is distance traveled by electron through this path for first path. Similarly, we calculate action for second path, which is given by this expression. Similarly, thus we have to add V plus T. Similarly, I calculated all action for all possible path, and we do total phase factor, not phase. Total phase factor is given by Feynman expression. Feynman expression, yes, this is the expression. S1, S2, this is the action of different paths. If you're going to plot the value of S1, S2, S3, Sn, then we'll get this expression. Here 2 pi by lambda is replaced here, H and H cancel, 2 pi over lambda, that is replaced by C plus the notation for that one. And again we take common, I, C, D is taken common, then I got this expression. This is geometric in series, and summation is having to this expression. And also, we know that net probability is obtained by summing the contribution from all possible paths. That is given by Feynman. And after absolute squaring of all sums, then we will get probability of intensity. If we introduce this concept in a raw expression, then we will get formula of intensity like this. And whether this formula is correct or not, I tried for benzene. In benzene case, current flows through only 2 paths. Suppose current enters here, then current can go through this way or through this way. Only 2 possible paths are possible. So in case of benzene or for Young's double slit experiment, there are only 2 paths possible. So in both cases, Young is 2. If we plot the Young is equal to 2 in this whole expression, then we will get a standard formula like this that we have. Therefore, this formula is correct. And same concept I used for fluorine. Current flows through this way, current flows through this way. I use Kirchhoff's law. Here, from here to here is D. From here to here again T. That is carbon to next neighboring carbon distance is taken as D. If you take action for all different paths, here total number of paths are 12 that I used using Kirchhoff's law. I found using Kirchhoff's law, and I got total paths 12. So I took total action for all paths and got 2D, 3D, 4D, 5D, 6D, because from here to here 2D, from here to here 3D. Likewise, different possible paths are possible. So I took all paths and then rearranged. Then again I got geometric series, and for geometric series, this is our formula. If we're gonna plot the value of M to L, then we got intensity if positive plate is connected here and negative plate is connected here. For this figure, for different arrangement, if this one connected here, then we have different number of paths. Then we have, again, but formula is same, and we can calculate the value of intensity. If intensity is maximum, that is transmission is maximum. If 0, then transmission, there is no current flow in the both of it, though it is connected to the source. And in case of C40, this is C40 transmission spectrum. So C40 which has C3 symmetry, C2 symmetry, this one. So in this case here at 0, this is energy scale, this is transmission function. So here at 0 region, this is increases here. Here value increases, here value decreases. In this region at 1.5, here is more transmission value, here is low transmission value. So in different region, here -2, it is more, it is around 0. So at different region, what we saw, transmission spectrum is different, and in this way, we can resolve structural isomers of fluorine. And that is conclusion, and we can detect structural isomers. Also, we can use fluorine as junction diode and transistor, and switching mechanism also is utilized. That's all.